Okay, I'm also recording this, so I have a some videos for reviews. So let me. I forgot to copy those other um, content. That's okay. So just enter here 30 degrees, 30 degrees. All right. Uh, See, the more I try to get things done fast, the more I will make mistakes. So what should I do? Slow down and grab that handle, make sure I pull it. So these are the XYZ readouts, and I'll even insert a title here. So I'll say here, this is angle. This is the reason I want to type it up. I want to show you how to label a column properly. You need a column name, which is angle. You also need a proper unit for degree. So this, on the other hand, this is AX and is in G. So how many 9.8 meters per second squared? So it's in G. So you can also type AY in G, AZ in G, and we'll have a calculated angle also in degree. All right. So to calculate the angle, we'll enter arctangent and the x coordinate over the z coordinate. I had a question, why the y doesn't change? Can someone tell me how do I change the y? The y, ay is like it's always close to zero. How would I make that non-zero? Yes, tilted in a different axis. So instead of tilting like this, right? This is all we're tilting at. We're just tilting this way. You get a lot of y values if you tilt it the other way. And if you tilt it in a generic way with x, y, z coordinates, you can calculate how you're tilting. So we're not getting there. That's a 3D. We're not trying to get all 3D, right? So we're only tilting in a particular direction that is read by the x and z coordinates. So if you just hit here, now this is the angle in radians. So what should I do? Convert this into degrees. I'll just use a function to do that because why would I remember the conversion factor? Okay, I don't have to. All right, too many sig figs because we're only able to read about 3 sig figs everywhere. So this should have about 3 sig figs. So press that button until you have 3 sig figs. And just double click the bottom right corner. This will automate all the formulas. There you go. See that even the formatting is following it. You should be learning all the tricks instead of trying to do this one at a time, right? So get one formula, format it properly, and then just autofill the rest. So this is how we should be doing it. Instead of, oh, I know how to do this, just type up more, right? But that will take some time. Even generating these labels can be done automatically. I don't know what happened. It's like, okay, here. Okay. It wasn't letting me uh, move my cursor for a bit. So let's file them. So the last number, last angle. Okay. So I first calculated the angle, and the next thing I want to do is average these angles. I have 5 trials. So okay with that, and also do a standard deviation among the 5 angles to see how accurate how spread out my angles are. And then I'll have a relative uncertainty calculated based on the two, and the relative error calculated based on the angle and the inclined planes readout. So let's calculate the average. This should be just average. And I'll select 1, 2, 3, 4, 5. 2, okay, here we go. So file them, close parentheses, and hit enter. And the standard deviation is just SCDEV. Also the same range of angles involved. Okay, so the standard deviation is an estimate of uncertainty. It shouldn't be displaying so many digits. it should only display one sig fig, whichever that is. I think it's 1 digit after decimal. All right. So what this reads is my angle reads 31.0 degrees plus minus 0.3 degrees. So that is the range that they were doing. I know who they were. They sent me their data, and this is what they were able to do. So among the 5 trials, there were some variations up to about 0.3. This covers 2/3 of that variation. Okay, so what exactly is the uncertainty, relative uncertainty? Uncertainty is not about how accurately you were able to reproduce the 30 degrees. It's about how you can say, okay, here I have 5 measurements, they vary. So I'm not certain about the measurement, individual measurements. We're not starting yet. We're starting in a few moments. All right. So this is equal to that, which is uncertainty, and divide by the expected, so that over that. And we'll display this as a percent style with a 1%. And the relative error is your measurement and versus the expected. So your measurement, I'll do an absolute value in case the numbers are different. So this is your measurement based on accelerometer. This is the expected measurement, 30 degrees, divided by the expected 30 degrees. And that can also format into a percent style. So what you are having here is you measure 31 plus minus 1.3 degrees. You're expected to measure 30 degrees. So your uncertainty is 1% relatively speaking. Your error is 3% relatively speaking. Because relative error is bigger than relative uncertainty, you were not able to confirm the 30-degree angle measurement for that particular trial. All right. So that's what I want you to have. And what else do you do? Well, you do this and copy paste them to the 35-degree angle. And that's not it. 40-degree angle and 45-degree angle. Even that's not enough because we want to check and make sure the formulas are still following the correct data. See that? I'm actually following the right data. Yep. So let's see 45 degrees. Am I able to confirm it? A lot of 0%. So I need to show a single digit that I can read. Unfortunately, I couldn't reconfirm that either because my tolerance is pretty low. I have a 0.2% of a variation among all my measured values, and I have a 0.4% of error of what I'm getting. But if you're just making a commercial bubble level that you sell for $20, I think this is pretty good. We can't really tell a 0.1 degrees. Right. Okay. So this is how you would analyze your data. I recorded it so you can watch it later. We can always discuss this in groups in person, right? Let me stop that recording now.